Okay, problem number 5. A street light casts a 50-foot shadow at the same time. Mr. Smith is a 6 foot. At the same time, Mr. Smith, who is 6 feet tall, casts an 8-foot shadow. So we're going to use proportion, and you want to use the same quantity over the same quantity. So, for example, you can have height over shadow. So what's the height of Mr. Smith? He is 6 feet tall. What is his shadow? His shadow is 8 feet. Well, what's the height of the street light? We don't know. But what's the length of the shadow? Well, that's on the ground. We can measure that. We determine that that's 50 feet. So then now we can cross multiply, and we get 8x equals 300. Divide both sides by 8, and we get 300 over 8. So you can put that in your calculator, and you can find the decimal equivalent. And that units will be in feet, and that's the height of the street light. Hello, this is Mr. Morton, and this is a first of many videos on second semester review packet for Geometry CP. Okay, for number 1, you're given 2 triangles, or that 2 triangles are similar. You have to find the scale factor. To do that, you simply use the order of the triangles and identify corresponding sides. So we will say 5 over 2, or we can write it as a ratio, 5 to 2. For 2 and 3, we can use our scale factor. Let's label AC X and EF Y. So to find AC, I would say 5 over 2, and that's equal to X over 4. Cross multiply, we get 2X equals 20. And once you divide by 2, you get X equals 10. For number 3, you can use the scale factor again. And this time I'm going to say 12 over Y. Cross multiply, so we get 5Y equals 24. And that is the same as, once you divide by 5, you get Y equals 24 over 5, or 4.8 as a decimal. Okay, 4A is absolutely true. If shapes are similar, the corresponding angles are absolutely congruent. And for 4B, what is the ratio of the areas? Well, you can use the scale factor to find that. So the ratio of the areas is similar to the ratio of the sides. You just square the 2. So we get 25 over 4, and this is our answer.